Hello, welcome to today's lesson on section 9.7. It's the last section of this chapter, and this section has no graphing, which I'm sure many of you would be happy to hear. Just solving. That's usually how we end each chapter. What we will do is we'll look at the general graphs for some of these functions just to confirm our answers, but obviously we're doing solving exclusively here. These are called solving quadratic systems, and that's because we're going to have two equations. That's why it's called a system. And some terms will be quadratic, meaning they'll have x squared and y squared terms. The way we'll go about solving these will be the following. We'll either use substitution. That's actually one of the first techniques we're going to use. Substitution or elimination, which you guys should be familiar with after taking Algebra 1 a couple of years ago. So there's no new formulas or specific concepts to talk about, so let's go straight to the examples. So we'll start with number 1. Now before I start solving, hopefully you realize that that will be a parabola, because only one squared term exists, and hopefully you realize that that will be a line. And we think about it, a parabola line can cross twice, can touch once, or we got something like this here, where there's no intersection. So these are the various answers we can get when you have a parabola and a line and you're trying to solve. My technique here will be substitution. And it should be pretty easy. Changing colors. So negative y equals negative 2x plus 3. So y will equal 2x minus 3. And remember, we have y squared minus 7x plus 3 equals 0. So we replace y with 2x minus 3. So very simple. 2x minus 3 squared minus 7x plus 3 equals 0. 4x squared minus 12x plus 9 minus 7x plus 3 equals 0. 4x squared minus 19x plus 12 equals 0. Factor it. You can use a diamond if you like. So you want to find terms that multiply 48 and add up to negative 19. That would be, let me think here, 3 and 16, both negative. So you have 4x squared minus 3x minus 16x plus 12 equals 0. Make that plus negative. Factor out x, you have 4x minus 3. Factor out negative 4. 4x minus 3 equals 0. So you have x minus 4 times 4x minus 3 equals 0. And so, of course, x will equal 4, or x will equal 3/4. What that means is that y will equal 5, or y should equal negative 1.5. And that's according to that right there. So your answers are 4, 5, and 3/4, negative 1.5. If you did try graphing these, the graph would look something like this. Which explains why we get 2 points of intersection. Okay, number 2. So you might want to pause the video, but think about what technique would you use to solve this system. If you said substitution, congratulations. Substitution would be the best way to go here. Substitution. There we go. Forgot how to spell. So, if you think about here, we got a line, and here we got a circle. So, we could have 2 points of intersection. We could have 1 or none. Those are the 3 situations we could have. So we already have y by itself in the second equation. So very simple. Work it out. Factor out of 10. Make it easy on yourself. Factor it. And so of course you just get x equals 3. And that means that y obviously is going to equal negative 3 times 3 plus 10, which is 1. So your answer is 3 comma 1. Which should make sense because if you were to graph this, okay, that was a horrible circle. But you have that. And if you graph y equals negative 3x plus 10, okay, kind of missed, but that would be your answer for that one. Okay, last one, number 3. This one's a doozy. Here we got ourselves, hopefully you recognize this as an ellipse. And hopefully you recognize this as a hyperbola. Now, for your technique, is substitution a good idea? No way, Jose. Not a good idea. Reason being is that if you were to substitute, actually, you know what? You could do substitution. It just might get a little messy. And you actually have to substitute a little bit carefully too. But elimination's easier. How can you tell? You can tell because these will eliminate if you add the equations. So let's stack them. So if we add the equations, gone. 10x squared minus 90x plus 200 equals 0. Factor out 10. See how easy that is to factor? So you get 2 answers, 5 or 4. So now what you want to do is figure out what y is going to be. Let's use I'm trying to figure out where the heck my highlighter went. There it is. Let's use that for substitution. So we'll change colors up. 5 squared minus y squared minus 16 equals 0. So 9 will equal y squared. Y equals plus or minus 3. Over here, 4 squared minus y squared minus 16 equals 0. So negative y squared equals 0. Y squared equals 0. Y equals 0. So we get 2 sets of coordinates. Or sorry, 3 sets of coordinates. And that makes sense because if your hyperbola looks like this, we know it's going to be sideways, not up and down, because x squared is positive and y squared is negative. And if your ellipse could look like this. So you could get 3 points of intersection. What do you think is the maximum points of intersection that is possible for these systems? That's something to think about, and I'll put it as a question in the Google Docs form. But here, obviously, we had 3 points of intersection. Okay, so I'm all done. Hopefully you liked the fact this is a shorter video, and I'll see you guys on Friday. Goodbye.